Hello everyone, and welcome to the last video in our series on Shiny best practices. So in this video, we're going to be exploring some code that I built for an app we're calling Crane Game. So this is the home directory for the app, and you can see that we've got two folders in here, which is something that we haven't had before. A data folder and a www folder. So the www folder just has all of the images that we're going to use in the app. And then our data folder has both the raw data and the data processing script that I use to clean it into the nice cleaned up smaller data that we're using in the app. And the reason that I have all of this in this repository is that we're really going for reproducibility here. So I want people to be able to see where the data came from with correct attribution, understand what I did to clean it up, and then see the data that's going into the app. And when you're sharing finished apps, you don't really necessarily need to leave all of this in here. You just need the data that you need to run the apps. I'm just keeping it all together in this repository to show you all, but this is something that I would want to host on like a GitHub repository or something later on. So if we come back into the main app directory, we're going to open up our app. And this is an app that just does a few things. So it shows us distributions of sandhill cranes counted in the breeding bird survey from 1966 to 2019. And you can filter the input using the slider. You see the number of cranes increases over time, both because the number of BBS routes increased, but also because crane populations have actually increased over the last several decades. And this is one of those times where we take a moment and we think about the input as, or sorry, we think about the outputs of our app as they relate to different types of people. So this is just a variation on what we've done before with adding markers to points. The only thing we've done differently is add a cluster, and I'll show you how to do that in a moment. But one of the things that we've taken care to do here is to emphasize the pattern in the data in a text form. So in addition to showing the data, we're also telling the app user through text that sandhill crane populations have increased over time. And having these sorts of informative captions is just a really nice, obviously already implemented way that we can make our apps accessible to people who are operating primarily through a text interface or who might be using like a text-to-speech. And we have to sort of use some of these workarounds like this because even though Shiny is picking up accessibility features really fast, there's still a lot to be developed in terms of accessibility, both in Shiny and in RStudio. So that's the first tab of the website. And notice for reproducibility and ethics, we are giving proper attribution, saying that we're just plotting raw data from BBS and that the data and the actual BBS analyses are available at this link. So if we come over to the Community Science tab, this is crane distribution at a different resolution. So this is a map of eBird locations over different months from 2015 to 2020. So even though this slider looks similar to sliders that we've seen before, it's actually a new input type for us. It's a text slider. So I'll show you how to implement the code. But the basic idea is that the user is moving through qualitative terms on the slider. So the fun thing about this app is that we can see by looking at the clusters of crane observations, the cranes are sort of marching north in the spring to breed on their northern prairies and wet meadows up here. And then as it gets to be fall and winter, we see them kind of retreat back down south to their southern wintering grounds. So it's just a really fun way to have a sort of a take on two different types of bird data. And this is one of the places where what we were talking about with automation and compartmentalization and preparation is really important because, as you know, if you've ever worked with eBird data or BBS data, those are big chunky data sets. So doing a lot of preparation ahead of time and thinking about what's really essential for the point that we want to get across saves us a lot of runtime here and makes a nicer engagement experience for our user. The next thing I want to show you in this app is this Crane Facts tab. And Crane Facts is just, it's just a fun little tab. First of all, to introduce an action button, which is another new thing for us. And also to show you how images work, and most importantly, to show you how we can use alt text. So we have two items of alt text here, one on the image and one on the button itself. So what this means is that if somebody's engaging with this page using a screen reader, their screen reader will read them this image description, and it will say, image description, a large flock of sandhill cranes standing and flying above the Platte River. And then it'll give the fun fact. Fun fact, omnivorous sandhill cranes use their long bills to probe wetlands. So that's a really easy way. This is just one line, and I'll show you, to make sure that we are creating user products that are accessible to lots of different types of people. And then same story when we have inputs like this. When we have our tooltip that says click for a crane fact, when we give instructions to non-visual users the same way we do to visual users, we're making sure that more people get to engage with our products. The last tab here is just our references tab. So this is where all of the data came from that I used in this project, including both the map tiles and the different types of bird survey data. So this is just part of our reproducibility and ethics efforts to make sure that we're properly attributing all of the data and tools that we're using to make our apps. So I'm going to close out of the app, and I'm going to come into the actual app code. So if you remember our key phrase from our Shiny Best Practices Concepts video, the idea here is as much as possible to do things once. So here we're loading all our libraries, that happens once, and then we're loading in a few different vectors of data. So we're loading in a pick list, which is actually kind of an interesting data structure, so I'll show you. So pick list is actually a data frame that contains the paths and all of the alt text for our crane pictures. So this is a quick way that we can make sure in that image shuffling thing, we can keep the right picture together with the right caption. This is our BBS data coming in here and our eBird data. And here we're going to open our UI. So you'll notice as we go into UI that we're taking full advantage of the indenting and commenting features. So we are dropping in an indent on each line basically. And you notice that we have open parentheses on lines by themselves with their functions. And then closing parentheses, we're doing the mirror image where we're bumping them back out as we close them. And you'll notice, as we talked about in our Shiny Best Practices Concepts video, we're leaving ourselves some nice little notes about what each parenthesis is as it opens and closes. And that's going to help us a lot when we're trying to track down rogue elements and figure out how all these pieces fit together. So just to give you a brief overview about the actual content of this user interface, this is our sidebar panel, which we've met before inside the sidebar layout. And we're just giving the user some text about background on sandhill cranes. And then here's our slider input, which we've seen before. The only difference here is that we're using years, which means that we're using the sep argument that drops the comma that you would typically use to denote thousands. So that makes our numeric vector look like years for the user. And here's what it looks like when we have a hyperlink. This is our link for the text BBS website that routes to information about the breeding bird survey. And there is our nice familiar leaflet output with our crane map. So that's that first panel with the BBS data. And you'll notice that we're following our ideas of doing things once We have packaged up all our data ahead of time. We've cleaned it up. We've limited what we need to look at. And we're thinking about the relationship between what the user sees, the data structure that we create, and the analytical products that are being put out to the user. Coming down into our next panel, we see it's quite similar. The only big change is this slider text input. And this is the new input we saw where users are moving from January to December. So we're using a pre-made vector called month name for choices. So this is basically the same as like a drop-down menu that we've seen before structurally. The only difference is that the user is moving from left to right, top to bottom through the vector instead of picking it out of a list. And this widget actually comes, this isn't in the base Shiny package, this actually comes from the Shiny Widgets package, which is a package that you can use to add on even more fun widgets than automatically come with Shiny. All right, so moving down into our Crane Facts panel, this is actually probably the most interesting one in terms of code. And this is one of those places, remember, that we were going to talk about accessibility. So remember I told you how that the accessibility features are one line of code? Well, here's that line. So it's actually just this line called title. This is one of the really exciting things that's been happening in Shiny in the last year or so, is that there's been a lot of development to just build in accessibility features. I'm very excited about it, and I hope that they keep working on it. So this is the label. That's what users see visually, and then title controls that little tooltip that pop up. And here we're also using something that we haven't formally talked about in the course yet, but that I noticed a lot of folks gravitating towards, which is this fluid row function. And Shiny conceives of space on a page as rows and columns, and they're nested. So by creating a row, we're creating a set of horizontal space that we can then fill with columns. And then you can fill your columns with more rows or more columns ad nauseum, and basically break up the space into a grid of whatever dimensions you need. So here we're just simply using the fluid rows to create a dedicated amount of space to think about, and we're going to align our pictures in the center of our row. And we're doing something similar here, and I could have probably written this more simply, but I'm going to do it to show you the row and column functions, where we're using width to determine the column, and it says 6, and that unit of 6 can be a little confusing because what that actually is showing that we want one column that takes up half the space. And that's because Shiny thinks about the rows and columns in units of 12. So it thinks about our column, our whole page, as being 12 units wide. And you have to tell it when you choose a column how wide you want that column to be out of those 12 units. So here we're making it 6, which is half the page. And then we're adding an offset of 3, which means that I want a space of 1/4 of the column to either side. So essentially what we've done is taken up the whole horizontal space with one column by designating these offsets. And then we're aligning it left within our column. So ultimately this kind of just creates like a center left appearance. And if that sounds like a whole crazy bunch of nonsense, I would encourage you to play around with some layouts and see what happens when you adjust these parameters. So moving on, here's our references. This is really simple. It's just a bunch of hyperlinks that go to the correct websites. So that's our UI. To sum up the new things that we added in UI, we played with this slider text input. We added some pictures, and we added some cool accessibility features where we have tooltips floating above the pictures and buttons, which are also new, to help users with screen readers navigate our app. So let's move on to the server of this app. And this is really one of those places that I'm talking about compartmentalization being important. This is a good example of what I mean. So In this server, we are doing something we haven't done before, and that's breaking up the processes where we're making data based on user inputs and the processes where we're making outputs based on that data. So this is this approach that I talked about in the last video, where we have a cascade of small functions rather than one big function. And the reason that I would advocate for this approach, especially when you're getting started, is because if we break a big function, it can be really difficult to figure out what's going on in there and really, really frustrating. Whereas if I break one of these small functions that just filter data based on user inputs, it's really easy to figure out because I can just make a text output, uh, add a text output to my server, and then make it print whatever it's doing into the app. Or I can just copy and paste it over to a blank script and play with it with different inputs. Having simple broken down functions like this will just make our lives much easier. And plus, I actually think it runs faster in a lot of cases. So this is going to be kind of a series of data processing functions. So we're making this reactive variable countDat, which is where we're going to let users filter the BBS data by year. So every time the user moves that slider and chooses a new year, countDat will update. And then we have its complement, which is eBirdDat, which is the same deal. Every time the user moves that text input slider, it's going to update the filter to the user's specifications. So we have these two data processing functions going on up here, and then we're going to make our leaflet maps like we have before. The only difference is that if you remember before, we had our data processing under the umbrella of the render leaflet. And while that works perfectly fine, compartmentalizing out our data processing apart from our creating our outputs, um, in addition to making things easy to debug, makes it easier to scale pieces of our app. Because say we wanted another output that used that same data set, we don't have to process the data set again. We can just call the data set like this, like we would a function, and then we can just make that other output. So structuring our apps like this, even if it seems silly when you have a small amount of data and a small number of outputs, makes it way easier to scale our apps as they grow. So here's our leaflet map. We're using a different provider tile this time. We're using one from OpenTopoMap, but the process is exactly like adding the Stamen app. And then we're adding those circle markers that we looked at before. And this is the fun thing, we're adding the cluster options. So this just, you can obviously change these as you like, but adding the clusters I really like, especially for big data sets, because it lets the user kind of get an overall high level understanding of what's happening with the data that changes as they zoom in and out. And then we're just going to restrict the user's view somewhat to make it hard to pan away from North America, basically. So here's our map with, I actually just realized that I said this backwards. This map is our eBird map. And this map here is our BBS map, but it doesn't matter because they're basically the same map with different data inputs. The only difference here is that we're adding these labels, which I just realized that I maybe forgot to show you. The labels are fun, so we'll go back to the app for a minute. So we added labels to our BBS app where when we mouse over them, they give us some information. So they tell us the number of cranes counted there and the longitude and latitude. And you can make these labels say whatever you wanted. So if you wanted to like name points by a site ID or something like that, you could do that. Or even if you just wanted to set up a system where you could just skim around the map and it would report longitudes and latitudes, you can do that too. So that's what the labels are about. They're very useful. I like them a lot. Now we move on to the picture part. And the reason I put this in here is that I think this workflow is going to be useful for some folks, especially folks who are thinking about like loading different rasters or different spatial elements and don't want to clutter up their workspace. So This is a very silly example of a pipeline that's going to be useful for us. So what we're doing is we're using this event reactive function to monitor what the user is doing. And in this case, it's monitoring for the user to press the show me a crane fact button. And when they do that, it just randomly samples that pick list, which remember pick list is our data frame of image paths and alt text data, and it just randomly grabs one. Then then down here, because remember we're compartmentalizing into data processing and outputs, we are calling our picktf, which we've just created using the button. And then we're going to pull out path, we're going to pull out alt data, alt text data, and we're going to pull out our fun fact. And then really simply, we're just going to render the image. So we'll render the image by determining a size, putting alt text, which shows up in the HTML source of the page if we inspect it. And then we are setting a title, just like we did for the button, where we're determining the fact that will float on the label with that image description. And then the last thing that we're looking at down here is really simple, our render text function, which I actually think is new for us, where we are just taking that same information from pickdf and we're grabbing the fact, and then we're just printing the fact, printing our crane fun fact. And even though, again, this is like a very silly little implementation, this is the first example of the place where this sort of compartmentalized workflow is really useful, because we have pickdf, which we've set up one time up here, and then we're calling it twice, once to make the picture and once to make the fun fact. And when we start to scale up what we're doing, this kind of logic where you break down your code into its essential components and make it cascade will really speed up our apps a lot, and it'll make it much, much easier for us as developers to move through and update things logically and eventually to scale to bigger projects. So that's all I have for this video. I really hope that you all enjoy the Crane app, and I'll put it up online so that you can play with it. And I hope that you got some useful implementation of our Shiny best practices, and hopefully some good code that you can take and incorporate into your own apps.